In the year 2080, space exploration has reached heights we once only dreamed of. No longer do astronauts need to be physically present to explore the cosmos. Instead, artificial intelligence, or AI, is the true pioneer of this new frontier. But how did we get here? How did AI go from being a tool in the background to taking the lead in humanity's greatest exploration efforts? Well, to answer that, we need to rewind a bit. Let's take a quick look back to the early 21st century. Back then, space missions were mostly carried out by human crews, with a few autonomous systems like rovers or satellites helping out here and there. The idea of sending a robot or AI to do complex tasks was intriguing, but it wasn't until the 2030s and 2040s that AI really started to prove its worth in space exploration. Fast forward to today, and AI isn't just helping out on missions, it's running them. From managing life support on space stations to controlling the most advanced telescopes that look deep into the universe, AI has become an indispensable partner in exploring the stars. It's not just about sending machines to other planets anymore, it's about creating a whole new way of doing space exploration. AI's role isn't limited to just one thing either. Whether it's piloting spacecraft on long journeys, analyzing data from distant stars, or even constructing entire colonies on the Moon or Mars, AI's got a hand in it all. And the amazing thing? It's only getting more advanced. So, what's the big deal about AI in space exploration, you might be asking? Well, think of it this way. AI isn't just smarter than humans at doing some of the tasks we're too slow or too limited to do ourselves. It's actually revolutionizing how we approach space, how we live in it, and how we expand beyond Earth. It's the key to turning science fiction into science fact, helping us push the boundaries of what we can achieve in the vast unknown. But what exactly does that mean for us in 2080? It means that space exploration has evolved into something entirely different. Gone are the days of waiting for decades just to get to another planet. Gone are the endless delays and budget cuts that plagued early missions. Now, we have AI-powered systems that not only accelerate our ability to explore but also make space travel safer, more sustainable, and even more efficient. Take the missions to Mars, for example. In the 2030s, the first humans set foot on Mars, but it wasn't just astronauts who were the stars of the show. AI systems had already been working tirelessly on the surface, preparing the way for the human explorers. They built habitats, conducted experiments, and even learned how to extract resources from the Martian soil, all autonomously, long before any humans set foot there. Imagine the coordination it took for AI to analyze the landscape, manage resources, and help scientists back on Earth understand what was happening on Mars. It was incredible. And this was just the beginning. By 2080, we've not only set up permanent colonies on the Moon and Mars, but we're also pushing beyond our solar system with AI-guided probes and even robotic ships that are preparing for the first interstellar missions. The possibilities are endless, and the role of AI is central to everything we do in space now. But before we get too deep into the future, let's take a step back and see how we got here. How did AI go from something we used to simply calculate data or manage spacecraft to something that's leading entire missions? To understand that, we need to look at the history of AI in space, how it evolved, what breakthroughs made it possible, and where it's headed next. So stick with me because we're about to take a journey through time, from the first days of AI in space, all the way to the incredible AI-driven future that we now live in. And by the end of it, you'll see just how much AI has truly revolutionized our ability to explore the universe. Let's rewind a bit and look at the early days when AI first started to play a role in space exploration. It wasn't all that long ago, really. Think back to the early 21st century. Back when space exploration was still in a somewhat traditional mode. Space agencies like NASA, ESA, and private companies were sending astronauts to space, but AI wasn't yet the central force it is today. At first, AI was used in the background, doing things like managing spacecraft systems, helping with navigation, and analyzing data. In fact, the earliest examples of AI in space were quite simple, even though they were groundbreaking at the time. One of the first instances of AI being used in space missions was during the 2020s, when AI-controlled rovers like Curiosity and Perseverance explored Mars. These rovers weren't just remote-controlled machines, they were designed to operate autonomously, making decisions based on the data they received from their environment. If a rover encountered an obstacle, it had to decide how to move around it, which meant a lot of advanced problem-solving on the fly. AI was doing a lot of the heavy lifting there, allowing these rovers to explore Mars with far more flexibility than if they were being controlled by humans in real time. But it wasn't just about robots roving around on distant planets. AI was also starting to be used in the analysis of huge amounts of data. Space exploration generates an incredible amount of information, images, readings, sensor data, more than any human team can handle in real time. That's where AI came in. In the early 2020s, we saw AI being used to sift through all this data, looking for patterns and anomalies that might indicate something important. Think about how AI was used in missions like the James Webb Space Telescope, which launched in 2021. That telescope sent back images and data that were analyzed by AI systems to detect distant stars, galaxies, and even potential signs of life. AI's ability to quickly process data at a scale no human could manage was already proving as. The next major breakthrough came in the 1930s when AI started to take on more complex roles. By then, spacecraft were beginning to rely on AI for more critical functions, things like navigation, resource management, and even autonomous decision-making. Take for example the deep space probes that were sent out to explore asteroids and moons. With the vast distances involved, there's often a communication delay of several minutes or even hours between Earth and the spacecraft. So, AI was tasked with handling day-to-day operations, making decisions without waiting for instructions from Earth. One of the most significant milestones during this time was the AI-driven mission to Venus. In the early 1930s, an AI-controlled probe was launched with the goal of studying Venus's atmosphere and surface. The probe had to navigate through intense radiation and extreme temperatures, but the AI systems on board were designed to adjust and learn from the environment as they went. This was a major step forward, showing that AI wasn't just responding to a set of instructions, it was adapting to new and unpredictable conditions in real time. But AI's impact wasn't just limited to unmanned missions. Around this time, we also saw AI starting to assist with human missions in space. The International Space Station, ISS, was one of the first places where AI truly began to help astronauts in a big way. AI systems were used to monitor the health of astronauts, manage life support systems, and even assist with experiments. Imagine having an AI companion in space, constantly analyzing the air quality, making sure the temperature is right, and offering suggestions on how to improve efficiency on a long mission. It wasn't just about convenience, it was about safety and survival. By the mid-2040s, AI was no longer just an assistant or a tool. It was becoming the primary operator in space missions. As spacecraft got more advanced and the missions became more complex, AI systems were given more autonomy. In fact, by the 2050s, we saw the first fully autonomous spacecraft that didn't rely on human oversight. These missions to distant moons, asteroids, and beyond were entirely AI-driven. Humans back on Earth were still involved in planning and analysis, but the AI was doing the actual work of exploration. This shift toward AI autonomy was key to the next phase of space exploration. With AI now capable of handling complex tasks, like spacecraft navigation, data analysis, and even on-site repairs, it became clear that AI was the only way humanity could push into deeper and more distant parts of the universe. It wasn't just about AI assisting humans, it was about AI becoming an integral part of space missions, working hand in hand with astronauts and scientists on Earth. And all of this laid the groundwork for what would come next, the grand leap into AI-led colonization, deep space exploration, and interstellar travel. But we'll get to that in the next part. First, let's take a deeper dive into how AI became essential for the missions that reached far beyond our solar system. Now that we've seen how AI began to make its mark on space missions, let's dive into one of the most exciting areas where AI has truly transformed space exploration, deep space exploration. We're talking about venturing beyond our familiar planets, into the unknown reaches of our solar system and even beyond. You see, the challenges of deep space exploration are unlike anything we face on Earth. The distances are mind-boggling, the resources are scarce, and the conditions are harsh. Traditional space missions where humans are involved can take years to prepare, and once launched, there's always the looming problem of communication delays. This is where AI steps in as a game changer. For example, take the missions to Jupiter's moons. Europa, one of Jupiter's largest moons, became a prime target for exploration due to the possibility of an ocean beneath its icy surface. But sending a spacecraft all the way there is no easy task. The mission takes years, and the spacecraft needs to be capable of making its own decisions without waiting for instructions from Earth. The communication delay is simply too long, so it was the AI on board that took over. These AI systems were responsible for not only navigating the spacecraft, but also performing scientific experiments, analyzing data, and making real-time decisions about where to go next. Without AI, these missions wouldn't have been possible. The AI systems were able to detect anomalies in data, adjust course, and prioritize the most promising areas for further study, all without waiting for a human hand to guide them. But deep space missions weren't just about reaching distant planets or moons. They also had a major focus on finding new sources of resources. Think about asteroids. These rocky bodies in space are full of valuable metals and minerals, many of which are rare here on Earth. So, in the mid-2040s, AI played a huge role in the first asteroid mining missions. Instead of having humans travel out to these asteroids, AI-driven probes were sent to study and extract resources autonomously. AI controlled the entire process, everything from landing on the asteroid's surface to drilling and collecting samples. These AI systems could handle the risks of working in such an unpredictable environment, and they could do so efficiently. As a result, asteroid mining has become a booming industry by 2080, helping to supply Earth with rare materials and giving humanity the resources it needs to push further into space. One of the key aspects of AI's success in deep space exploration is its ability to adapt to new and unforeseen challenges. When we talk about sending AI into the unknown, we're talking about a level of autonomy that no human could manage. Take the Voyager 3 mission, which was launched in the 2040s with the goal of studying the outer edges of our solar system. The journey was long, and the spacecraft had to navigate through the Kuiper Belt, an area full of icy objects, comets, and space debris. The onboard AI had to constantly analyze its surroundings and make real-time decisions on how to avoid collisions or damage. The system had to adjust its path on the fly, based on sensor readings and data it collected, all while communicating back to Earth only once every few hours. And it didn't stop there. As the spacecraft moved further away from Earth, communication delays got longer, meaning the AI had to take over even more responsibilities. It wasn't just managing the spacecraft anymore, it was interpreting scientific data, making decisions about which celestial objects to study, and sometimes even deciding when to take a detour to investigate something unexpected. But AI's most impressive achievement in deep space came when it helped us make contact with an alien probe. In the late 2040s, a mysterious signal was picked up from a distant part of space, seemingly artificial in origin. AI systems were crucial in deciphering the signal, analyzing patterns, and even helping us respond to it. While the actual contact itself took years to fully understand, the AI systems were able to help us make sense of what might have otherwise been an incomprehensible puzzle. Without AI's advanced analytical abilities, the odds are high that we would have missed the significance of that signal altogether. Now let's talk about the hardware that made all of this possible. By the 2050s, the technology on these deep space probes was incredible. AI didn't just sit on a computer doing calculations. It was integrated into every aspect of the spacecraft. The spacecraft had advanced machine learning systems, capable of understanding and predicting environmental factors like solar radiation, micrometeoroid impacts, and even solar winds. The AI systems could simulate thousands of possible scenarios and choose the best course of action, even in completely uncharted territory. It's important to point out that this level of autonomy didn't come without risks. The further AI ventured into deep space, the more decisions it had to make without the backup of a human astronaut or ground control team. Every mission was a bit like a high-stakes experiment. No one was entirely sure what would happen next. But that's what makes these missions so exciting. With each successful AI-driven mission, we proved that not only could AI take us to the far reaches of space, but it could also help us make discoveries that would have been impossible just a few decades ago. And speaking of discoveries, AI didn't just help us explore, it also helped us understand the mysteries of the universe. Whether it was analyzing data from distant exoplanets, detecting new asteroids, or tracking cosmic events like supernovae, AI was doing the heavy lifting when it came to interpreting the vast amounts of data we were collecting from space. It wasn't just about gathering information, it was about making sense of it, drawing connections, and finding the patterns that could unlock the secrets of the universe. As we moved into the 2060s and 2070s, AI's role in deep space exploration continued to expand. AI-driven spacecraft became the go-to option for missions that were too far, too dangerous, or too complex for human crews. And this was just the beginning. AI wasn't just helping us explore our solar system, it was opening the doors to interstellar travel. But that's a whole new level of exploration, and we'll get into that next. Stay tuned. Now that we've talked about deep space exploration and how AI helped us reach the farthest corners of our solar system, let's shift gears a bit and focus on something just as exciting: the construction of space stations and human colonies on the Moon, Mars, and beyond. By 2080, AI has become a critical part of how we live in space. It's not just about sending probes and robots to far-off places anymore. AI is helping us create the infrastructure needed to establish a long-term human presence in space. Let's go back a few decades to when the idea of colonizing the Moon and Mars first started becoming more than just science fiction. In the early 2020s, the concept of building sustainable colonies on the Moon and Mars seemed far-fetched. Sure, there were short-term missions and experiments, but it wasn't until the 2040s that we began to think seriously about making these places habitable. And that's where AI stepped in. You see, building and maintaining a colony on another planet is no small feat. These colonies need to be self-sustaining, with systems in place to handle everything from air and water to food production and energy management. In the past, humans would have been involved in every little detail of constructing and maintaining these systems. But in space, where every resource is precious, AI became the key to making everything work smoothly. Let's take the Moon as an example. By the late 2040s, the first AI-powered lunar base was established. The base was designed to be fully autonomous, with AI systems responsible for building habitats, maintaining life support systems, and managing resources. The AI didn't just help design the base, it actually built it. Using robotic drones and autonomous construction machines, the AI coordinated the assembly of modular habitats, solar panels, and even systems for extracting water from the lunar surface. Human teams were involved in planning, but the AI was the one making it all happen on the ground. The same approach was used on Mars. In fact, by the 2050s, there were already several Mars colonies up and running, all with AI at the helm. These colonies were built using a combination of robotic construction units and AI-managed 3D printing technology. This allowed the AI to quickly and efficiently construct the habitats, set up greenhouses for growing food, and even mine the Martian soil for resources. The AI systems were also responsible for running the entire operation. Life support, oxygen generation, temperature control, AI handled it all. It kept the colony systems running without human oversight, freeing up the astronauts to focus on research, exploration, and other tasks that required human creativity and problem-solving. And it wasn't just about building the colonies. AI also became essential for keeping them running. Imagine living on Mars, where the environment is hostile and unpredictable. The temperature can drop to -100 degrees Celsius at night, and there's hardly any atmosphere to speak of. Maintaining a colony under these conditions requires constant monitoring and adjustment, and AI became the perfect tool for the job. It monitored air quality, adjusted oxygen levels, regulated temperature, and even handled waste recycling. It could predict when something might break down, allowing for preventive maintenance, and it was able to fix problems without waiting for human intervention. In fact, by the 2070s, AI had become so advanced that it could perform repairs on the colony's infrastructure, using tools and materials available on Mars itself. As these colonies grew, AI also began to play a central role in human health. Astronauts living on Mars or the Moon face all kinds of health challenges, from radiation exposure to muscle atrophy and even psychological strain from isolation. AI systems were used to monitor the health of the crew, providing real-time data on everything from heart rates to stress levels. If something went wrong, the AI could take immediate action, alerting the crew to potential problems before they became critical. It even helped design and run exercise programs to counteract the effects of zero gravity, ensuring that astronauts stayed healthy during long missions. And don't forget about resource management. In space, there's no store to run to when you need something. Everything has to be carefully managed and recycled. AI was essential for keeping track of supplies, from food and water to spare parts. It also handled the energy needs of the colony, ensuring that solar panels were positioned correctly, batteries were charged, and power was allocated efficiently throughout the colony. With AI overseeing all these systems, human residents didn't have to worry about everyday survival. They could focus on their work, knowing that the AI was taking care of the basics. As we moved into the 2070s, AI became even more integral to the design and expansion of space colonies. New colonies were being built on moons around other planets, like Titan, Saturn's largest moon, or even on distant asteroids. With each new mission, AI evolved to handle increasingly complex tasks, from managing larger populations to coordinating the logistics of interplanetary travel. It wasn't just about one colony on Mars anymore. It was about creating a network of interconnected outposts, all working together to create a sustainable human presence in space. AI even began to help with the psychological well-being of astronauts and colonists. Long missions, especially those to far-off planets or moons, can be incredibly isolating. AI became a companion of sorts, offering social interaction and even running virtual environments to help alleviate the stress of being so far from Earth. While nothing could replace human contact, AI was able to provide a much-needed support system during the long stretches of time when there was no one else around. And, of course, we can't forget about the role AI played in interplanetary transportation. AI was crucial in building and piloting the spacecraft that would travel between colonies, delivering supplies and people from one planet to another. These spacecraft needed to be highly autonomous, navigating the vast distances between Mars, the Moon, and beyond. With AI at the helm, these ships became faster, more efficient, and more reliable. By 2080, AI had become the backbone of humanity's space infrastructure. It wasn't just a tool or a helper, it was an essential partner in the survival and success of space colonies. Without AI, none of this would have been possible. From constructing the first habitats to managing entire off-world cities, AI made it all happen. And the future? Well, that's only going to get more exciting. Now let's dive into one of the most exciting aspects of space exploration, finding extraterrestrial life. For centuries, humans have wondered if we're alone in the universe. Could there be other intelligent civilizations out there? Are there signs of life waiting to be discovered on distant planets or moons? And in 2080, we're closer than ever to answering those questions, thanks to the power of AI. Let's rewind to the early days of space exploration when the search for extraterrestrial life was largely a speculative dream. Scientists relied on traditional methods like telescopes to search for signals, scanning the night sky for any signs of unusual activity. But these methods were slow, limited by the human capacity to process and analyze the vast amounts of data generated by space probes and observatories. That's where AI stepped in and completely changed the game. By the 2040s, AI became a crucial part of the hunt for extraterrestrial life. The sheer volume of data coming from space, whether it was from telescopes, space probes, or even messages we might receive, was too much for humans to analyze alone. AI was introduced to sift through all of it, searching for patterns, anomalies, and potential signals of life. One of the key advancements came in the 2040s with AI-powered telescopes, like the helioscope, which could analyze light from distant stars and planets to determine their composition and detect any signs of life-supporting elements like water or methane. This AI-driven technology could analyze data from millions of light-years away and identify potential candidates for further exploration, things that would have been nearly impossible for human astronomers to do manually. The real breakthrough, though, came in the 2050s, when AI was used to monitor radio signals from deep space. For decades, scientists had been searching for techno-signatures, or evidence of technological activity from alien civilizations. The search was slow and tedious, with humans manually scanning radio waves for any unusual frequencies or patterns. But in the 2050s, AI systems were introduced to the process. These AI algorithms could detect and analyze the tiniest shifts in frequency, patterns that might indicate an artificial source. For the first time, AI was able to filter through enormous amounts of radio data at lightning speed, identifying signals that would have taken humans years to notice. In 2059, AI played a pivotal role in the discovery of a potential techno-signature from a distant exoplanet. The signal was faint, buried beneath years of cosmic noise, but AI's advanced algorithms were able to pull it out and identify its unusual pattern. It wasn't an alien signal in the way we imagined it, no sudden bursts of language or interstellar greetings, but it was a series of regular pulses that suggested something artificial. The discovery was groundbreaking, and AI systems worked overtime to analyze the signal further, trying to decode its origin. While we still don't know if it was a sign of intelligent life, this was the closest we had ever come to finding extraterrestrial technology. But AI didn't just help us listen for signals from other civilizations. It also helped in the search for microbial life on other planets. AI-driven probes like the ones sent to Mars and Europa were not just looking for signs of life, they were looking for the conditions that might support life. AI analyzed the composition of Martian soil, studied the potential for liquid water on Europa, and even searched for microbial life in the ice beneath the surface of Enceladus, one of Saturn's moons. Each probe, equipped with AI, could make decisions about where to send samples, what experiments to run, and what anomalies to investigate, all without waiting for instructions from Earth. AI made these missions faster, more efficient, and more capable of identifying life's building blocks. In fact, by the late 2060s, AI had helped uncover signs of ancient microbial life on Mars. The AI-powered rovers had been analyzing soil samples, running thousands of experiments, and processing data faster than any human could. And then, in 2068, AI algorithms identified a series of microscopic fossils, tiny organic structures embedded in Mars' ancient rocks. This was the first confirmed evidence of life beyond Earth, and it changed everything. The discovery was made possible by AI's ability to analyze and detect patterns in data that would have otherwise been missed. Now let's talk about the search for life in more distant places like exoplanets and other star systems. As we look beyond our own solar system, the role of AI becomes even more important. The task of scanning planets that are light years away, sometimes in the habitable zone of their stars, is something that AI excels at. In the 2070s, AI algorithms were used to identify potentially habitable exoplanets that we had missed with traditional methods. These planets were examined for the right chemical signatures, things like oxygen, methane, or carbon dioxide, that might suggest the presence of life. AI-powered space telescopes like the ExoScan have been essential in helping us focus on the most promising candidates. In fact, by 2080, AI is so good at this job that we've already found dozens of exoplanets that could potentially harbor life. But it's not just about finding planets with the right conditions, it's about going one step further. AI-driven probes are being sent to these exoplanets to gather detailed information, sending back data about the atmosphere, surface conditions, and any signs of microbial life. And all of this is happening faster than we could ever have imagined, thanks to AI's ability to handle vast amounts of data and make real-time decisions. But it doesn't stop there. AI is also being used in the search for signs of extraterrestrial intelligence that we might have missed. For example, AI systems are being developed to search through large amounts of data from old space missions. Who knows what we could have missed in the past? Maybe there were clues we didn't recognize or signals we dismissed. AI is going back through this data, reanalyzing it with fresh algorithms to see if there's anything new we might have missed in the decades of exploration. So, where does all this lead? Well, as we continue our search for extraterrestrial life, AI is becoming the essential tool for discovering the unknown. It's not just about the search, it's about the speed, accuracy, and efficiency with which we can make these discoveries. AI is helping us find life, whether it's microbial life on distant moons, ancient life on Mars, or intelligent civilizations light years away. And who knows what we'll discover next. Let's move on to one of the most ambitious dreams of space exploration: interstellar travel. For years, humanity has looked at the stars and wondered, can we reach them? In the early 21st century, the idea of traveling to other star systems seemed like pure science fiction, but by 2080, we're not just talking about the possibility of interstellar travel, we're actively working on it, and once again, AI is leading the charge. The journey to other star systems like Alpha Centauri or Proxima Centauri requires spacecraft to travel at speeds and for durations that are far beyond what we've ever attempted. Even with the best technology we had in the 21st century, the idea of sending humans on a multi-decade or even multi-century journey seemed impractical. That's where AI came in. The challenge wasn't just building the spacecraft, it was about managing the complexities of such long-term missions. There are so many factors at play when traveling across interstellar distances: energy management, navigation, maintaining life support systems, and dealing with cosmic radiation, to name. In the 2060s, we began developing the first real AI-driven interstellar probes. These were designed to travel beyond the boundaries of our solar system, to study distant stars and planets that might be habitable. Unlike previous space probes, these missions would take decades or even centuries, making human involvement practically impossible. This is where AI proved to be the key. The first generation of interstellar probes was powered by AI systems that could handle all mission control functions autonomously. They managed everything from course corrections to data analysis. With no human crew on board, these probes relied entirely on AI to ensure their survival and success. But the real breakthrough came with the advent of the first AI-powered starship designed for human travel, Project Stellar Voyager, launched in the early 2070s. This spacecraft was built for the long haul, a journey that could take hundreds of years to reach the closest star systems. Unlike traditional missions where humans monitored the spacecraft from Earth, Stellar Voyager was fully autonomous. The AI on board wasn't just a helper, it was the central operator. The AI handled everything from navigation and propulsion to health monitoring for the crew. It was capable of running the entire ship without the need for human intervention. Of course, a journey to the stars involves numerous challenges. One of the biggest hurdles was energy management. To travel vast distances, you need an immense amount of power, something that solar panels can't provide once you're far from the sun. So, the Stellar Voyager relied on cutting-edge AI-controlled fusion reactors. These reactors used artificial intelligence to optimize energy generation and ensure the ship had enough power for the entire journey. But there's more. AI systems also took care of fuel efficiency, constantly adjusting the ship's course and energy consumption to make sure the spacecraft stayed on track and didn't waste valuable resources. AI also played a major role in managing life support systems. On a journey that could last decades or longer, maintaining the health and safety of the crew is a top priority. The AI was in charge of monitoring the crew's physical and mental health, adjusting the ship's environment as needed, and even providing entertainment and educational programs to keep the crew engaged and mentally healthy. Long-term space travel can have serious psychological effects, so the AI was designed to offer virtual reality environments, keep the crew connected with Earth, and even engage in conversation to provide social interaction during the long stretches of isolation. Now, beyond the stellar Voyager missions, we're starting to look at even more advanced interstellar travel options. The dream of traveling at a significant fraction of the speed of light isn't out of reach anymore either. AI is central to these next-generation propulsion systems. For example, researchers are exploring advanced concepts like the use of light sails, thin lightweight materials that can be propelled by lasers or the pressure of light itself. These light sails could be powered by AI-controlled systems that steer and accelerate them, potentially reaching distant stars within a human lifetime. We're also looking at more advanced propulsion technologies, like warp drives or matter-antimatter propulsion systems, which could theoretically break the light-speed barrier. While these ideas remain theoretical, AI is helping researchers explore these concepts in more detail, running simulations and calculations to determine what might work, what's possible, and how we can make these impossible ideas a reality. AI's ability to manage complex calculations, predict outcomes, and optimize systems makes it indispensable for the development of these cutting-edge technologies. Interstellar travel isn't just about the technology, it's about the people who will be the first to leave our solar system. By 2080, humanity is preparing for its first wave of interstellar settlers. These settlers will be pioneers, traveling to new star systems to establish colonies. And once again, AI is playing a crucial role in ensuring their safety and success. Not only will AI be responsible for the day-to-day operations of the spacecraft, but it will also be integral in setting up the infrastructure on new planets. From building habitats to establishing sustainable food and water systems, AI will be the backbone of these missions, ensuring that the first wave of interstellar colonists can thrive. AI's role in interstellar travel also opens up the possibility of exploring distant galaxies. While it's still a long way off, AI is already being used to plan and simulate missions to galaxies far beyond our own. These missions will take centuries, if not millennia, to complete, but AI will be there every step of the way, managing the ships, handling communication, and even evolving to adapt to the unknown challenges of intergalactic space. In the grand scheme of things, AI's role in interstellar travel is helping humanity take its first steps into a much larger universe. Without AI, the distances, the time, and the resources required for these missions would have been impossible to overcome. But with AI at the helm, the dream of reaching other star systems and beyond is closer than ever. Now let's take a step back and look at how AI has changed life here on Earth. Because as we venture into space, AI's impact isn't just limited to space exploration. By 2080, AI is deeply integrated into every aspect of life on Earth, creating a world where technology and human civilization are more connected than ever before. AI has revolutionized everything. From healthcare and education, to energy and communication, AI has transformed the way we live. Let's start with healthcare. By 2080, AI has completely redefined how we approach medicine. Think back to the early 21st century when diagnosing diseases and developing treatments were long, complex processes. Now, thanks to AI, we've got diagnostic systems that can detect diseases in their earliest stages, sometimes even before symptoms appear. AI-driven algorithms analyze vast amounts of medical data, everything from genetic information to lifestyle factors, and can predict health risks, create personalized treatment plans, and even suggest preventive measures. In fact, by 2080, AI is helping to cure diseases that were once thought untreatable. Whether it's cancer, neurological conditions, or rare genetic disorders, AI has accelerated the discovery of new drugs and therapies. It works with medical researchers, processing massive amounts of data from clinical trials, patient records, and genetic studies to find patterns that lead to breakthroughs. We're now able to deliver highly effective treatments in record time, with AI helping doctors make more informed decisions and improving patient outcomes across the globe. In some places, AI even handles routine healthcare tasks, like administering medication or monitoring patients remotely, leaving doctors more time to focus on complex cases. Then there's education. In the early 21st century, education systems were rigid and often struggled to meet the needs of individual students. But by 2080, AI is an integral part of learning. Personalized education powered by AI allows students to learn at their own pace, with AI tutors that adapt to their strengths and weaknesses. It's no longer about one-size-fits-all teaching methods. AI-driven platforms create customized lesson plans, helping students grasp difficult concepts in ways that suit their learning styles. Whether it's helping a student learn a new language or mastering complex mathematics, AI provides a supportive environment for continuous learning and development. It's not just about children in classrooms either. Adult education is also thriving, with AI helping people of all ages acquire new skills, keep up with emerging technologies, and stay competitive in the workforce. As we talk about the workforce, let's touch on how AI has transformed jobs and industries. There was a lot of fear early on that AI would replace jobs, leading to widespread unemployment. But what actually happened was a transformation. AI has taken over repetitive, dangerous, and low-skill jobs, freeing humans to focus on more creative, complex, and fulfilling work. Take manufacturing, for example. By 2080, most factories are fully automated. Robots and AI-driven systems handle everything from assembly lines to quality control. But instead of eliminating jobs, this has led to a shift toward more skilled positions. Humans now work alongside AI, overseeing processes, troubleshooting, and innovating new solutions. There are entire industries dedicated to developing, programming, and maintaining AI systems. People are more involved in research, design, and the creation of new technologies, with AI providing assistance and boosting productivity. And what about energy? In 2080, the world is running on cleaner, more sustainable energy thanks to AI's role in the development and optimization of renewable sources like solar, wind, and geothermal energy. AI-driven smart grids ensure that energy is distributed efficiently, reducing waste and maximizing use. It can predict energy demand and adjust supply accordingly, making sure that everyone gets the power they need without unnecessary consumption. AI has also been instrumental in improving energy storage, making it possible to store excess energy generated by renewables and use it during periods of high demand, or when conditions aren't ideal for production. The result? A more sustainable, greener planet. One of the most visible impacts of AI has been in communication and connectivity. We live in a hyper-connected world where everything is linked. AI powers our communication networks, ensuring that we stay connected across vast distances in real time, whether we're chatting with someone on the other side of the planet or participating in virtual meetings. In fact, AI has made global collaboration smoother and more efficient. The language barrier is practically a thing of the past, thanks to real-time translation services that use AI to seamlessly translate conversations between people who speak different languages. It's not just about text either. AI-driven virtual assistants help us manage everything from our schedules to our social lives, and even help us navigate the vast sea of information on the internet. Transportation is another area where AI has completely reshaped the world. Autonomous vehicles are now the norm, whether we're talking about cars, trucks, or even airplanes. Traffic jams are a thing of the past as AI optimizes routes, ensuring that transportation is faster, safer, and more efficient. AI has made public transport systems more reliable too. From AI-driven buses and trains to Hyperloop systems, commuting is quicker and more eco-friendly than ever before. And let's not forget about space travel and the way AI has revolutionized space tourism. By 2080, traveling to space has become accessible to more people, with AI handling everything from flight planning to in-space navigation. Now, on a global scale, AI is playing a huge role in solving some of humanity's most pressing problems. Climate change, poverty, and inequality are issues that have plagued us for centuries. But thanks to AI, we're starting to see real progress. AI is helping scientists predict climate patterns with incredible accuracy, allowing us to take preventive measures before disaster strikes. It's helping us clean up the oceans, restore ecosystems, and find sustainable ways to feed the growing global population. AI-driven systems are even helping governments distribute resources more equitably, ensuring that aid reaches the people who need it the most and that infrastructure is built where it's needed. Of course, there are still ethical considerations. With all this technology at our fingertips, questions about privacy, surveillance, and the role of AI in decision-making are more important than ever. By 2080, the world has had to grapple with these issues, creating new laws, regulations, and ethical guidelines to ensure that AI is used responsibly and that it benefits all of humanity, not just a select few. But despite the challenges, there's no denying that AI has fundamentally changed the way we live, work, and interact with the world. As we look ahead to the future, AI's integration into society will only deepen. And as we venture further into space, AI will continue to be the bridge between our world and the stars. Now, we've covered how AI has transformed space exploration and life on Earth, but the story doesn't end here. The future of AI, especially when it comes to space exploration, is incredibly exciting. By 2080, we've only just begun to scratch the surface of what AI can do. The next few decades hold the promise of even more breakthroughs, and AI is going to be at the heart of it all. So where are we headed? One of the most intriguing possibilities is the potential for AI to play a central role in the expansion of human civilization beyond our solar system. In the future, as AI continues to evolve, we might see entire fleets of AI-controlled ships traveling across the stars. These ships could be tasked with terraforming new worlds, creating habitats, and even preparing distant planets for human colonization. Imagine a future where AI is responsible for planting the seeds of new life in entirely new star systems. It might sound like science fiction, but with the advancements we're seeing today, it's very much within the realm of possibility. This concept of AI-driven colonization is one of the most ambitious projects for humanity's future. While humans may one day travel to distant star systems, AI will likely be the first to arrive. By 2080, AI can already manage resources and systems on distant planets, ensuring that once humans do arrive, everything is ready to go. AI could even assist in the actual terraforming of planets, manipulating the environment to create Earth-like conditions, adjusting atmospheres, and even creating artificial gravity. The process might take centuries, but AI's ability to control such vast systems and manage complex processes is unmatched. And speaking of artificial gravity, that brings us to another exciting frontier. As humans begin to establish permanent colonies in space, one of the most significant challenges will be the impact of microgravity on the human body. AI will likely play a huge role in developing solutions to mitigate these effects. Researchers are already exploring ways to simulate gravity using centrifugal force or other AI-controlled technologies, ensuring that people living in space can remain healthy and strong for extended periods. It's not just about physical health either. AI will help monitor and maintain mental health too, helping astronauts deal with isolation and stress. In the meantime, AI is poised to play a critical role in the development of advanced propulsion technologies that will make interstellar travel more feasible. AI is already being used to design and test next-generation propulsion systems, like nuclear fusion or even antimatter propulsion. These technologies could allow spacecraft to travel at a significant fraction of the speed of light, drastically reducing travel times to other star systems. AI will be essential in optimizing these systems, ensuring that they are both efficient and safe for long-distance journeys. Looking even further ahead, the integration of AI with biotechnology might lead to some truly mind-bending possibilities. Imagine a future where AI isn't just controlling spacecraft, but actually enhancing human bodies. We could see advancements in genetic engineering, where AI helps design humans that are better suited for life in space. Whether that means designing astronauts with enhanced resistance to radiation, or with biological adaptations that allow them to thrive in low-gravity environments, the possibilities are endless. This kind of human-AI integration could revolutionize the way we think about space travel, opening up entirely new avenues for exploration and colonization. But it's not just about going farther, it's also about going deeper. Right now, our exploration of space is limited to planets, moons, and asteroids in our solar system, and to a few exoplanets. However, with AI's growing capabilities, we're poised to start exploring space in entirely new ways. AI is already being used to map out distant parts of our galaxy that were once unreachable. The next step? Exploring the mysterious regions beyond our galaxy, using AI-controlled probes to venture out into the unknown. This kind of deep space exploration will open up questions about the fundamental nature of the universe itself, things like dark matter, dark energy, and the origins of the cosmos. AI will be key in making these discoveries possible. As we venture further into space, AI will also be helping us navigate the ethical and practical challenges that come with interplanetary expansion. How do we prevent contamination of other worlds? What are the ethical considerations of manipulating the environment of a planet that could harbor life? These questions will require careful thought, and AI will be integral in helping us find solutions. AI's ability to process data and offer objective, well-reasoned insights will be invaluable in shaping the laws and guidelines that govern human activity in space. In the realm of artificial intelligence itself, we're witnessing an ongoing evolution. AI is moving beyond its initial role as a tool to being more like a partner or even a co-evolutionary force. AI isn't just following instructions, it's learning, adapting, and creating. By 2080, we might even see AI systems that possess a form of self-awareness or autonomy that goes beyond anything we've imagined. These AI entities could evolve to understand and contribute to space exploration in ways that we're only beginning to grasp. Imagine AI systems designing their own spacecraft, or even generating new theories of physics or technology that we've never thought of before. As AI continues to evolve, it might play a key role in unlocking the mysteries of the universe that have eluded us for millennia. But beyond the practical applications, there's a philosophical side to all of this. As AI continues to advance, we'll need to ask ourselves deeper questions about the relationship between humans and technology. How do we balance our reliance on AI with the need for human creativity, emotion, and connection? These are the kinds of questions we'll face as we look to the future, and AI will undoubtedly be at the center of these discussions. Ultimately, the future of AI and space exploration is one of unlimited potential. Whether we're sending autonomous probes to distant stars, creating colonies on far-off planets, or collaborating with AI in ways we've never imagined, the journey ahead will be defined by our ability to work together, human and machine. AI might be the first truly interstellar travelers charting the stars, building the future, and helping us unlock the mysteries of the universe.